Let's take a look at the domain and range of log functions for a second. Now, to find the domain and range, what you need to do is take the inside argument of the log, and it doesn't matter what base it is. This is understood to be base 10 down here, but it could be any particular piece. What you do is take the inside portion that I have highlighted there, and you just have to say that that must be greater than 0. Not greater than or equal to, strictly greater than 0. Now, when you go through and solve for x, I always want to keep x on the left-hand side, and I'm going to show you this for writing interval notation. So I'm going to subtract 1/2 from both sides first. That will leave me with a negative x is greater than negative 1/2. Now, when I multiply both sides by a negative 1 here, I have to change the direction of the inequality, which will then give me x is less than 1/2. Now the reason I did it this way is in order to put this inside of interval notation, sometimes it's helpful to think about this as a number line. This is 0, this is 1/2. Everything does not equal 1/2, but it's everything that is less than. I go in the same direction of the arrow. So that means for interval notation of this, I go from negative infinity all the way up to 1/2, and this is the domain. Now, the domain also gives us our vertical asymptotes. My vertical asymptote will be at x is equal to 1/2. Let's take a look at what this looks like as a graph. So as I'm looking at this piece, what are we noticing? This is the graph of our function. It is a decreasing or decaying function. Now, as I'm looking at some of these points that are really important, we do have this point right here, meaning that when x is 0, our y value is negative 0.301. You get that by directly putting that into your calculator. Your other intercept right here is at negative 1/2, 0, because if you plug in negative 1/2 inside the equation, you'll get the 0 as your output. Now, one of the things that we talked about before was the fact that we have this vertical asymptote. Let me erase this real quick. So our vertical asymptote is going to appear at, this is 1, and this here is 1/2. So this 1/2 line is our vertical